This is the second part of the quantitative treatment of locus. We want to find the equation of the locus with an algebra or geometric approach. So here is example 3. We have points A and B, and then the movement is so that twice PA is PB. Now, if you look at these details, it looks strikingly familiar with example 1. The 2 points are the same, 1 minus 2 and 7, 4. The movement rule is very similar. PA is PB. But instead of PA is PB, the sole change is twice PA is PB. Now, we can still do it with algebra. That never mind the difference. We just translate the whole thing into an equation. So we have twice PA. PA will be something like this. Alright, that is the square root. Is PB, right? So PB will be something like this. And then with a square root. So PA will be x and y, and then 1 and minus 2. PB will be once again x and y, 7 and 4. Alright. Perhaps it is a good idea to take square on both sides. And what is inside is x squared and y squared minus 2x and 4y and 5. Alright, inside the square root. And then on the right hand side we have x squared and y squared minus 14x minus 8y plus 65. Alright. So the only difference now is this is multiplied to 4. Alright. So we can collect all the x squared, y squared term, etc. So we have 3x squared and 3y squared and 6x and 24y, right, minus 45 equals to 0. Alright. Oh, it can be divisible by 3, so that is x squared and y squared, and 2x and 8y minus 15 is 0. It turns out, now we didn't expect it at first, it turns out that the locus is a circle. Alright, it's no longer a straight line. Just changing this number into a 2 will change the locus into a circle. It is not a straight line. Alright, so we have very little understanding of the geometry. Some common mistake will be thinking that, okay, if it is point A and point B, if PB is twice PA, so we can have the point here, and that is 1 to 2, and then we draw the straight line. So this is the locus of P. Now this is very wrong, because the calculation shows that the locus of P is not a straight line. Alright, if PA is half the distance of PB, or 2 to 1, it does not mean that it is a straight line passing through the point of division 2 to 1. It's a very common mistake when people are dealing with this K times PA equals to PB. The best approach is to use the algebraic approach. Alright, just do a literal translation of this equation into something we can calculate. In this case, we use the distance formula and then we simplify. In the end, we find out the surprise result that this is a circle instead of a straight line. Alright, so this is a variation about what we dealt with previously. Okay, so let's look at example 4. Now, example 4, we have a fixed point A. Alright, it's at 8 and 0 and 8. It's on the y-axis. Then it is on the y-axis. 0, 8. We have the straight line y equals to 4. Y equals to 4 is a horizontal straight line. Alright, the horizontal straight line goes like this. Y equals to 4. Alright, so I guess this is 4. And we want to find the moving point P, so that the distance between P and L is the same as the distance between P and A. So PA will be this distance, and distance between P and L will be this. Right, so P will be x and y. Now it's not difficult to express PA. PA will be just like this, right? We did that numerous times before. Will be x and y. And point A will be 0 and 8, right? I forgot the square root. Right, this is PA. But how do you describe the distance between P and L? Because we have no idea, we have very little idea about this point, alright? But don't worry, we know that if the point P is y, that means the distance from the x-axis here is y. Right, this is y. And then the red line is y being 4. That means the distance between the x-axis and the red line is 4 units. So we get that the distance between P and L will therefore be P minus 4. Distance between P and L will be y minus 4. Now this is the more important part in this question. Do you get this? The blue one is y. The blue one here is y. The orange is 4. So that is the perpendicular distance between P and L, and that is y minus 4. Alright. So now we can equate these two. On one hand we have x squared and y minus 8 squared. Take the square root. That is the distance of PA. On the other hand, we have the distance between PL will be something like this. So we just simplify the equation. So that is x squared and y squared minus 16y and 64. On the other side, that would be y minus 4. Take the square. So that is y squared minus 8y plus 16. Alright. So it ends up x squared minus 8y and 48 equals to 0. This is a parabola. This is a parabola. You can change y as the subject. Alright. So y will be x squared divided by 8 plus 6. Alright. This is a parabola. So once again, this is another algebraic attempt for the locus question. Alright. So this is the end of the part 2. In part 3, we'll look at some past paper questions.